Cold in place recycling, following from Trenton's presentation. What is it? Cold in place recycling, top 4 to 5 inches, usually. Occasionally 3 inches, but never less because it's so difficult to pave. That's the reality. So 3 inches is exceptional. 4, 5, if you're in Canada, everything is 6, cold in place recycling. They have one fix, 6 inches depth on the East Coast. Exactly as Trenton described, we're looking for a reasonably good base, and we're only addressing the asphalt problems. So if you were looking at a project selection and you've got base failures, think full depth recycling in situ, or mill it all out and cold central plant. But we're going to talk about this zone right now. So your project selection, if you worked in the city and you were thinking, I have to recycle 4 inches and I have to hold grade, so maybe I've got a pre-mill, you've got to mill 2, you've got to have at least 6 inches of asphalt. So that is your rough guide of your project selection to get into this zone for cold in place recycling. Trains, there are different ideas how to do cold in place recycling. This is what would be classed as a multi-train. There'll be a bitumen truck here, maybe emulsion or AC, normally emulsion in these trains. Emulsion truck here, which will pipe binder all the way back to this tanker here. This is a water truck. This is a down-cut milling machine loading crusher, screening, mixing plant. The binder is fed from this tanker into the pug mill. It's then dropped into a windrow that's straddled by the tank, and it goes back to a pickup machine to a paver. That was the traditional way to do cold in place recycling in North America, and that evolved in the 80s. So that's a long history of cold in place recycling in North America. But this is Utah, for example. All of these trains were really working in the West exactly as Trenton indicated. But a long, long train. Where you have to be particularly careful is your windrow. If you're working with an emulsion and you're in the West and it's hot, then you're going to get some breaking in that windrow. Then it's all down to the size of your screed, how you can knock those lumps down to try and get a ride and minimize the thickness of the asphalt. It works, you've just got to manage. So a lot of contractors in the West will actually start the job before sunrise for that very reason. Things have moved on since the 80s to different technologies. This is a job I did in just outside of, it's Twin Peaks Park, just outside of San Francisco. The job called for cement spread, so we spread our cement. There's a bitumen truck. There's our recycler. We're down cutting the asphalt to control our gradation. We're simultaneously adding the binders into the mixing chamber. We load directly into a paver, pave out with a high compaction screed, roll, and we're done. So that would be classed as a single unit recycler. Much more compact, so we can now, the scope of work for cold in place recycling, or the scope of opportunities, is now not just lower volume roads very straight. We're now working in cities, townships, urban areas, highways, lower volume roads. So now we're attacking everything with cold in place recycling because we have some new technology. Binding agents, really the same as we looked at yesterday. You have in this instance, your base material is now going to be milled. Similar to what we talked about yesterday with cold central plant, it's millings. Most popular binders are emulsion with water for compaction, foamed asphalt with water, cement and emulsion, and cement and foam. I would say the market is right now 60% of the jobs are foamed asphalt, 40% of the jobs are emulsion for cold in place recycling. If you're anywhere near a city, anywhere near traffic, it's always foamed asphalt, so we can get the traffic on as fast as possible. And we're going to make another band granular base. It is a base, exactly as Trenton's first slides. It needs to be sealed with an appropriate seal. Just a note on cement. Following Brian, you heard Brian yesterday, he's quite right. You do get some kick on strength, on particularly the wet strengths, if you put cement in. However, the function of the cement, or the dust fraction, originally was as a filler to give us fines. So it started on the foam side that we were looking for fines content of 3 to 5%. So to make sure we got that, we were putting in 1% cement or other dust fraction, but usually cement was used because it was easy to get, it's easy to spread, it's dense, and it sits on the pavement at that thinness. Then it was seen that there was advantage on the wet strengths. Emulsion never did put cement in, but now they've started to do it somewhat when you've got cloudy days or it's a little cooler and you're going to try to accelerate the break on the emulsion. So that's that 1% cement is just sucking a bit of water out there. So that's where the cement came in. With foam, we've used all sorts of fillers in the past, baghouse dust, all sorts of stuff, but it's not so easy to get always, and it's sometimes difficult to spread. Cement, you call a guy, he spreads the cement, that's it.
For cold recycling using bituminous binding agents and cement, a Streumaster binding agent spreader applies a layer of cement onto the surface to be paved. Computer-controlled metering gates ensure the highest spreading accuracy. They are followed by a water tanker truck and a bitumen tanker truck. The recycler draws water and bitumen via connected hose lines. By means of push rods, the 3800 CR pushes the tanker trucks and thus sets the work pace. The powerful milling and mixing rotor with a working width of 3.8 meters operates in the down-cutting process, achieving an improved unit size and preventing slabs from breaking out. A microprocessor-controlled injection system ensures the precisely metered addition of bituminous binding agents and water in the mixing chamber. At the same time, the pre-spread cement is added. Via the conveyor, the processed homogeneous construction material is transported directly into the material hoppers of the downstream Fugala paver performing the paving. The flexible loading permits optimum material management for paving true to grade and slope. New base layers are characterized by maximum quality. Final compaction is carried out by ham tandem vibration rollers as well as a rubber wheeled roller, ensuring a closed surface structure.
I think that should be it. So you see the difference in this process. We're mixing here and we're paving here. So we're not exposing the recycled material to windrow. We are handling it as minimal as possible to avoid segregation. And we're looking to use a high compaction screed where possible. So we're going to get a ride at the screed and then a seal as a seal. Just a couple of really quite important points on cold in place recycling. And it's very similar to what we talked about yesterday with the cold central plant. You need 2 spray bars as a minimum. So this spray bar will sit on top of the mixing chamber, and this is going to inject your binder, either the foamed asphalt or the emulsion. So you will put in your lab mix design and this will pump that mix all day long. And you should not change this, exactly as we said yesterday on the cold central plant. That value, if it's 2.5 or 3.3 for emulsion, has come from the lab, and that is your mix for the day, until you're told differently. Your second independent spray bar, which also sits on top of the cutter housing, is for your compaction water. This you are going to have to change quite regularly during the day, because now we're in situ. Our in situ moisture ahead of us is changing as we're going down the pavement, depending on the crack pattern, or trees, or whatever else. So this, you're going to be looking to change on the run. Changing this water does not affect this spray bar. So that's why they have to be independent. That's what just to give you an idea, that's what a spray bar looks like. So this is inside the cutter housing here. You're injecting through these 18 nozzles. So most specifications, I'm not sure Virginia, call for a minimum 12-foot, 12-foot-6 cutter. So if you're doing a 20-foot road, which you get, say, in upstate New York, you're going to do one pass injecting 12-foot, then you're going to cut the spray bar off by 4-foot, and you're going to do your second pass injecting 8-foot. So you don't double dose that 4-foot width. Computers do, on all machines now, it doesn't matter whose machine it is, they do everything for us now. So simply, this would be a screen for a cold in place recycler. You would put in the depth you want to recycle, typically 4 inches, 10 centimeters, the width you want to recycle, the density of the material that you are going to recycle, and then your mix design. So 2.5% foam, 1% water, whatever it is. Enter those values in the machine, and that will produce that all day long. If you want to change your water, so this control panel on our equipment anyway is just at the groundsman's head here. If he wants to change the water, he simply selects the water spray bar here, changes the value, and that's it done. So he's actually standing on the ground next to the material and can change the compaction water value. So we can change and react to in situ changes very quickly. And then they do accumulations of how many square yards you've done a day, how much you've processed. So good data for the road owner. And at any one time, the DOT inspector or the road owner inspector can look at the screen and actually see what's happening in the cutter. So is it producing 2.5% foam? It'll show you on the screen. Am I getting 3.3% emulsion? It'll show you on the screen. How they work, whether it's a track or a wheel, you've got a pickup just sensing the rotation, which converts that to a speed factor for your computer, which tells your pump how fast you're going and how much, therefore, material you're processing, how fast the pump should go to get 2.5% binder in. If you slow down, the pumps automatically slow down. Speed up, pumps automatically speed up. That is an essential feature every machine should have, so that you take the quality control out of the operator. He can't react fast enough, so the machine has to do all that for you, particularly when you're working on jobs where it may be hilly or you've got a lot of twists, a lot of bends. You have to have equipment that's going to react to changes in speed. Foamed asphalt, not sure why we put this in, but anyway, in case anybody hadn't seen it, we keep talking about it. Hot AC stream, typically 6422, that's most popular across USA. 18 injection points, open the valve, hot AC comes into a water stream. So this pre-water is important. You have to have the water stream running first, whether you're on cold central plant or cold in place recycling. This has to be in place first for the AC to hit it. If the AC is coming through, then you turn the water on, it has no effect. So you have to have this pre-water stream. Then you're going to just simply change the state of the AC from an unmixable product. If we just inject straight AC like they still do in Michigan, unbelievably, and wonder why they just have long black stripes. You can't mix straight AC. So all we're doing here is changing the foam into foam or bubbles so we can mix it. There's no chemicals, it's just a change of state. Animation. That's just a bucket full of foam. So if you go back to Trenton's half-life description yesterday, you see how you're raising up. That's your expansion. And then the rate of collapse is going to be a half-life, as Trenton described yesterday. But you want lots of nice bubbles just to mix. And you want some stability. So why we're looking for 6 to 8 seconds is just some stability in the foam condition to get it mixed. All basic stuff for coal-in-place recyclers. There's nothing out of the way. Obviously, we've got to have meters at work. Wrap gradation is going to be usually predetermined before we start injecting the binders to give us that speed range. Depth is monitored. All these machines now have sonic sensors for your depth control. You can add slope, so you can correct the road to a 2% slope while you're recycling. Recycling additive percentage is critical. If the design says 2.5, that's what it has to be. And don't change it. Doesn't matter what it looks like, because it's not asphalt. Yep, right? Smoothness is important. You know, I'll show you a job we did in New Jersey in a little while, and we put a micro on. So the selection of the screed made the job. If we'd used a rock and roll screed like this, you're never going to choose a micro surface finish. Moisture, if you're working in a city, you're going to try and keep that as low as possible to get the traffic on as fast as possible. The more moisture that's in there, the longer it takes to get the moisture out to get the traffic on. Density, everything about recycling is density. It's your only measurable value as you go through the day. You know, we talked about yesterday taking a sample, taking it back to the lab, preparing bricks. That's 5 days. So if we're working 2 miles a day, we're already 10 miles down the road by the time you get that break. And that relationship between this guy and the guy who's controlling the moisture, whether it be at the plant or at the coal-in-place recycler, is critical. That he's telling, yes, you're good, or no, I need a bit more, I need a bit less. And on the bigger jobs, intelligent compaction is starting to come in. I think you're trying that on 64. There's a section, intelligent compaction's coming in, I think. And then, this is always a top of a discussion. When can I put traffic on? Spec will say something, reality is to put it on straight away. This was working with Buzz, NCAT, US 280. So this job, this was well prepared. I have to say this was really well prepared job. Everything I think went really quite well. 4 test sections, 2 CIR, 2 central plant, foam and emulsion. We pre-milled the job to 1.4 inches. And why we did pre-mill to 1.4 inches, when you recycle, there's also fluff factor, whether you're paving with central plant or cold in place, at least 10%. So to get back, so if you want to put an inch on, as we did here, you've got to mill a little bit more than an inch to get back to your 1 inch after compaction. The job was split between foam and emulsion. We're using a 12'6" machine. The emulsion mix design was 3.3% emulsion and 3% compaction water. And the foam, if I remember, the foam was 2.5% and 3% compaction water. Both were very similar. We just on one section we pushed an emulsion tank, on the second section we pushed a bitumen tank or an AC tank, both into the same paver, compacted, and a fog seal. So we pre-milled. These millings were, tell me if I'm wrong, were not used for the central plant because that was already pre-graded millings that we had. So they went to stockpile. Both jobs called for 1.5% cement. We were very fortunate on this job. We had a good spreader. It actually had a 12-foot head, so we got a really quite uniform distribution of the cement. A lot of jobs you'll see you've got a hump here and a hump there, and it's not even funny. Going down the road, just as the animation, and loaded directly into a paver. We've got just pretty much a strike-off screed here, so you can see how much fluff we've got sitting on the adjacent lane, and we've got to compact that down to below 1 inch of this lane. So that's the difference between using a high compaction screed and a regular just strike-off screed. We were on this job doing, it was a short job, but we were still doing 18 feet a minute. Spray bars were showing 3.3 compaction, 3.2, 3.3 emulsion. It's always hunting a little bit, but the average is 3.3. And if that was a longer job, that would equate to around 290 tons an hour. So that is really quite reasonable production. Material was loaded into the paver directly, so there's no windrow at all, just continually moving. So here's your mix at the screed. It's going to tell you in your face, pretty much, do I look good or do I look bad? Rollers, again, yesterday we talked about it. While it's moist, it looks asphalty, but you still got some uncoated stones in there. And it looks nice. Nothing wrong with that. Looks very similar to your job from central plant. Recycling is good. It looks really good. Here's a finished section. So now you can see we had that much of the adjacent pavement. We've compacted down to where we need to be. So all of that fluff now, we've compacted down. So you can see we had probably in total 3 inches of fluff sitting there. Then that's with the 1 inch overlay. This is not like this. This is just this is a man who had too much beer the night before putting the white line down. It's not like that. The ride was very, very good. These are cores, you can see. The materials, you've got foam and you've got emulsion. They cored pretty well, I think. And, you know, it's a nice mix. It really is. Concept in Jersey, which is a little different. Finish on this one. New Jersey, like everybody else, got a lot of asphalt over concrete, reflective cracking. It's gone to hell. Put new asphalt on, 6 months, it's gone to hell again. So let's try recycling. Even if the cracks come back, it didn't cost as much as putting the asphalt in. So the idea was we would cold in place recycle 3.5 inches just to kiss the concrete. So we're going to reveal the concrete. The DOT were a little concerned how the recycled material would sit on the concrete. Would it slide around or would it stick? So we decided to use a spray jet paver, where once we reveal the concrete, we can inject a tack coat on the revealed concrete and then pave directly on top of it, so we get that bond. So that was new to them. In fact, the whole thing was new to them. And then, on top of everything else, we were just going to put a micro surface on. So this was a little out there, but you got to sometimes be innovative, take a risk. So this is our train. It was a foam job. AC, it was 6422 again. Rear load directly into a spray jet finisher, high compaction screed. This is an emulsion tank sitting on top of it. We're working 29 feet a minute, 380 tons now. So here is our revealed concrete. You can see we're just kissing the concrete. Here is our spray jet finisher. We're applying a tack coat here directly onto the concrete. Here's our recycled material that we're going to pave on top of the tack coat. So on this screed, we have vibration, tamper bars, and pressure plates. So we were getting somewhere between 93 and 96% compaction at the screed because we were working at these slower speeds. That screed has a chance to work. If you work at 100 feet a minute, forget using a high compaction screed. So we were getting 93, 96 at the screed. So here you see we have a hopper insert here. So this is 29, 30 feet a minute. Always have to have a man with a shovel. You got to have something to lean against. So there's the concrete just there. Then here's our tack. So that's on both wings and between the tracks. Recycled material directly on top. Pave it, compact it. We used, it was a day late getting there, but because we got damaged concrete underneath there, we chose to use oscillation compaction as opposed to vibratory compaction, just so we could maybe eliminate some beating up of the concrete with the roller. So the oscillation went well, the concept was well, our densities were good. That's our finished mat. So we would start 7:30 till about 1, do half a mile, tidy everything up. 2 o'clock, we were putting the micro on. So going back to when should you seal it? We sealed it. And then we put the stripes on. And to all intents and purposes, the public had a completely new finished road, half a mile long, in a day. This was one lift of micro. Just after this job, the governor decided to cut off all funding for roadworks in New Jersey. It never ever got the second lift to this day. This was 2 years ago. Sorry, 1 year ago. So it's still sitting with one lift. Our field results were good. So field was 69 dry is against the lab 74, 65 against the lab 66. So it was a nice mix. But if we look at your specification yesterday, it's no good. Let's dig it out. It was construction, so this is what it looked like originally, the road. So it looked like immediately after we've done both lanes now. August, we had a little bit, I must say, it's not a hell of a lot of traffic, maybe it's 15, 18,000 vehicles a day. And then I was up there in March, over the winter, still looks pretty good.